If I'm looking at the conditions for the ambiguous case of the sine law, the possibility of an ambiguous case solution only exists if the given information is of the type SSA, two sides and an angle not in between the two sides. Often, the context of the question and diagram provided makes it obvious if the solution is acute angle or an obtuse angle, but if it doesn't give us enough information in the question and it doesn't show us a picture, then there is potentially two possibilities. So either the equation has one solution which is acute, or it has two solutions, one which would be acute and one which would not. When solving for the required angle in the triangle using inverse sine, the calculator will provide an acute angle, and we can determine an obtuse angle by subtracting the acute one from 180. The three angles inside the triangle have to add up to 180, but if the given angle added to the obtuse angle is greater than 180, then the obtuse angle solution is not going to work, which means there's only going to be one possibility. We're going to take a look at in the chart here. So, if I'm completing the table below for a situation where one angle has been given and an acute angle has been calculated using the sine law, well, if I have a given angle is 25, the acute angle for this is 33 degrees, then the missing angle would be 122 degrees. And all three of these are going to add up to 180. At the same rate, if I took the obtuse version of this acute angle, it's going to give me 147 degrees. If I take the 25 plus 147 and subtract that from 180, I'm going to get 8 degrees, which means that now I have a second possibility. I can say that it's going to be 25, 147, and 8. We can do the same thing for the next examples. I'm going to say that, well, the missing one for this one is going to be 126 if I use the first two. And there's one possibility. For the next one, it's going to be 134. For the next one, it's going to be 83 degrees. And for the last one, it's going to be 62 degrees. If I'm looking at the obtuse angles, well, if I have the acute angle of 24 for this one, then the obtuse version of that is going to be 156. And if I have 30 plus 156, that's already bigger than 180. This is not possible. I can't have these two angles together inside of one equation. So, I'm going to take a look at the next one. If my acute angle is 21 degrees, then the obtuse version of that would be 159 degrees. 25 plus 159 is already going to be bigger than 180. This one is not possible. If I have 43 degrees as my acute angle, then 137 degrees is going to be my obtuse angle. 54 plus 137 is already bigger than 180. This is not possible. And if my acute angle is 64 degrees, then my obtuse angle is going to be 116 degrees. 54 plus 116 is 170, which means I could have a third angle of 10 degrees. So this one is possible. So I can see that for the obtuse angle possibilities, I can have the 30, 131 and 19, 25, 147 and 8, or the 54, 116 and 10. So not all possibilities are actually going to work. So we can take a look at what the pattern is and say that if, when I'm solving this, the acute angle is greater than the given angle, well, take a look. If I have the given angle and the acute angle was bigger than that, there's one case. Given angle, acute angle is bigger. Here the acute angle is smaller, 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 and given angle and acute angle is bigger. Anytime that my acute angle when I'm solving it is bigger than the angle I'm given, I have two possibilities. If the acute angle is less than the one given, I'm only going to have one possibility for the triangles. So if I take a look at how this fits in here, I'm going to say find all the possible measures of angle C in the following triangles. For angle ABC, A is 50 degrees, side length A is 7.5, side length C is 9.5. So I'm going to have A, B, C is going to be 50 degrees, side length A is going to be 7.5, and side length C is going to be 9.5. And we're going to be solving for angle C. So I'm going to say that sine of angle C divided by 9.5 is going to equal sine of 50 divided by 7.5, or sine of C is going to equal 9.5 times sine of 50 divided by 7.5. And that's going to give me 0.9703, which means that angle C is going to be sine to the -1 of that, which would give me approximately 76 degrees. Well, as soon as I take a look at this, I can say my given angle is 50 degrees. My acute angle in here is 76 degrees. Because 76 degrees is greater than 50 degrees, I'm going to have an obtuse possibility as well. So that means that I could have an obtuse possibility in this case, and I could have a second triangle where C is going to be obtuse, which means I'm going to draw this a little bit differently. I'm going to draw it so that I can see that this is still going to be 50. So I have A is still going to be 50. I'm going to have angle C here is going to be obtuse. Angle B, this is still 7.5, and this is still going to be 9.5. But now I'm going to have this obtuse angle in here. I can solve for what the obtuse version of this is going to be because it's going to be angle C in the second case, 180 minus 76, which means that this would be 104 degrees. So if C is either 76 degrees or 104 degrees, then there's my two possibilities. Taking a look at example B, well, what did they state for B? The only difference for B is they flipped the values of A and C. So the side lengths are going to be a little different. Let's see if it gives us different possibilities. Let's do this in blue. So some of the information is the same. A is going to be 50. I can call this C, I can call this B. But now, this is going to be 9.5, and this is going to be 7.5, which means now I'm going to state that sine of C divided by 7.5 is going to equal sine of 50 divided by 9.5. Sine of C is going to equal 7.5 times sine of 50, all divided by 9.5, which is going to give me approximately 0.6048. So angle C in this case is going to be sine to the negative 1 of 0.6048, which is going to give me 37 degrees. If this angle is 37 degrees, then in this case, 37 is less than 50, which means that I'm only going to have one solution.